what is a vehicle auxiliary, what is it, and why do you have to worry about that? Well, the first auxiliary there in every vehicle is power brakes, power steering, air conditioning. Now, conventional old vehicles did not have that, but today's vehicles have power brakes, power steering. I remember when I was young, you need to be really able-bodied person to be able to steer the vehicles. Your hands used to pain after every drive. Now power steering you can even do like this. Power brakes, easy to apply brakes, otherwise you have to really apply a lot of force. Air conditioning was not there at that time, today it is there. These are called auxiliary because they consume energy. Where will the energy come from ultimately? It would have come from petrol in a petrol vehicle, it will come from battery in a electric vehicles. So, to the extent that these things consume electricity, my range will go down and I have to worry about it. Not only I have to design these things, but I have to worry that it impacts the range. So, as I told you, in a petrol vehicle it was hydraulics, the moving petrol engine with hydraulics was able to convert it to any speed, and through hydraulic pump, belt and shaft, not very efficient, you are able to drive the power brakes, power steering and air conditioning motor. Air conditioning also has a motor, you would have driven the motors. On the other hand, for electric vehicles, battery in electric vehicles drive motors for brakes, steering and air conditioning. All that we need is probably a different voltage, so you need DC-DC converters. So, they are much easier. Remember that battery used in both petrol vehicles and electric vehicles. In a petrol vehicles of today, there is a dynamometer which converts in petrol engine and charges the battery. In electric vehicles, well, main battery is enough, you do not need auxiliary battery, a DC-DC converters is used because low voltage and low power. You remember headlights, tail lights, flashlights, vehicle interior lights, motors for wipers, windows, all kind of sensors, communications, entertainment, vehicle control unit, guidance, rear view projection, all this requires electricity. All these are part of what is called auxiliary energy. So, at this point I think I have done enough to give you another assignment, and this assignment where we will talk about torque, speed and some amount of auxiliary is what we will talk about it. Essentially this is a very quick introduction of auxiliary. There is a separate chapter where we will talk about auxiliary in detail. Now I come to a very important part for both. One you are used to, other it is a totally new and it is a mind boggling. What will you do? Petrol pumps and the charging stations. Petrol pumps for petrol vehicles, charging stations where you charge the battery in a charging station. This is the infrastructure that a state has to create, and I have to go and either charge my vehicle or get my petrol. Petrol pumps has been created over our last 100 years, you do not even know about it, you do not even talk about it. Well, you know about it, you use them, but a lot of investment has gone in. And what has happened, initially there used to be a lot of subsidy, gradually they break even, so you do not have to, there is a business. Charging stations are new, in the beginning you do not know what to do, and therefore there are lots of issues, and once you put it, gradually it will become a business and you will not have to worry about it. So, this is the infrastructure required. Vehicle storage requires regular recharge. So, petrol pumps will have a large petrol tank underground. Petrol tank, you have to worry about its safety, you have to keep the petrol tank filled, so that when a vehicle comes, in a few minutes you can fill the petrol. Takes few minutes. I know people who gets very worried if it takes more than 2 minutes. They start honking. So if there are 3 or 4 cars and each pump takes 2 minutes for a vehicle, the one which is behind has to wait. But 2 minutes, 3 minutes per vehicle, so it's not that bad. You can put multiple pumps also. And it has been built in over 75 years. Electric vehicles on the other hand require charging stations to charge vehicles. Fortunately, there is a power grid available all over. So in petrol pumps, you have to actually bring the petrol in large petrol tanks and put it into that. That process, from the refineries you are going to bring the petrol, has been set up. For electric vehicle, the grid is already there. Now, is the grid capable of giving all the extra energy required for all the electric vehicles? A different issue. But that grid is used for your homes, offices, your factories. As you add air conditioner, you draw from the same grid. So, grid is very, very widely available. So, that part I will say even better than petrol. It is there in every home. Every home can be your petrol pump for electric vehicle, charge vehicle. Every office can be. The question is, petrol you could fill in 2 minutes. What about electric vehicles? Charging. That's where the difference is. It takes long, and in fact I should say long, it takes real long. How long? What is the impact of it, etc. We will look at it. How long will it take to charge the battery fully? That is the question that I am asking. Well, ideally, lithium ion battery that we use in our laptops, cell phones and petrol vehicles should charge slow, 5 to 7 hours, moderate temperature. That is what is going to give you best life. And remember, batteries are expensive, you do not want it to be changed. Ideally, whenever possible, you like to charge it in long hours. So, slow, that gives you the best life. So, what do? I charge overnight. Overnight is good because temperature is also low, which is good. Overnight charging at homes is very, very easy. That is ideal. Of course, what if you want to charge faster? If I run out of electricity on the way and I have to charge, I am not ready to wait for 5, 6, 7 hours. So, then you will require fast charger. And a fast charger which can charge the vehicle in about an hour. Now, what do you do for that an hour? Stand at the charging station with your hands in your pocket, keep walking, keep on looking at your watch. Is it 1 hour over? Every 3 minutes you think that, and it is a long wait. In fact, the first set of such chargers were designed in Japan, and they defined a charging standards. How do you charge? We will come to standards later on. And they call this standard CHAdeMO, CHADEMO. And what does CHAdeMO means? In Japanese means, let us go and have a cup of tea. I put the vehicle on charge, let us go and have a cup of tea, spend half an hour, 45 minutes, 1 hour, even for fast charging. So, ideally where will you charge if you have to do fast charging? When you go to a shopping mall, or even slow charging, you go and shop, or you go to a restaurant. 1 hour is all right. But remember that this 1 hour charge, if you charge it very often, it impacts the battery life. You had purchased a battery, you said 2000 times you can charge and discharge, and you started charging fast most of the time, you find the battery life goes to half. That means you have to replace the battery very frequently. Your costs are very high, and we require of course batteries with chemistry which allows this. In fact, if you take any battery, it does not even allow it, it will spoil even faster. And generally you have to use more expensive batteries, anyway battery costs are high. So, fast charging is something that we need and therefore have to give, but not something the most desirable from battery point of view. And then there are super fast chargers, where you try to charge in 15 minutes. This is even require even more expensive battery. And still you get nowhere like petrol filling. Couple of minutes. And if you have two cars waiting for ahead of you for charging, you can forget about it. So, EV charging stations would be different from petrol pumps, and probably the key difference between the vehicle and the. Now, there is another element that is there in a vehicle control unit. A vehicle control unit communicates with battery. There is a communication between battery and controller, typically using a protocol called CAN. It is a physical layer CAN protocol. It may even have external wireless interface. There may also battery may have other interfaces like GPS, load sensors, inclination sensors, etc. This is a typical vehicle control unit, other than the battery, a vehicle control unit, and it manages motors and controllers. So, it is there when you try to speed up and put your accelerator, the vehicle control unit will say now you accelerate. So, that is the what is finally going to control things. You want to apply brake, it is the vehicle control unit which will try to decelerate and convert the energy back into electricity and charge the battery, regeneration. The vehicle control unit may also collect data during drive. What is the temperature, what is the speed at which you went to, all these parameters can today in electric vehicles very easy to capture. And you can download you can even download parameters, even remotely download, because if this vehicle control unit has a wireless interface, GPRS, I can download parameters and say the motors change these parameters in motors or in batteries. The characteristics will start changing. It also allows things like what is called geofencing. Geofencing is basically saying the vehicle will not go outside this geographical area. Whenever it goes outside this geographical area, stop the vehicle. It will not work. Limiting temperatures. If it has gone very high, stop operation. Limiting speeds. We can send it to a vehicle saying, don't allow speeds beyond a certain point. Now remember, some of these things user may like, some things user may not like. So what will you use or not use is a different matter, but these things are possible just like through a vehicle control unit. As I had pointed out, in choosing battery, you have to worry about the power requirement and the range requirement. Range requirement, what is the distance that you want to travel, and power requirement, how much power you want to use. Energy used, as I pointed out earlier, is power into time, how much power you used every instant of time, integrate it and you take, that is a total energy that you use. Or if you have been driving, every meter how much energy you use, integrate power over all the meters and you get the energy. So, this is the energy required, you need to compute and need to figure this out, and then gradients may result into higher power energy usage. So, I talked about it, all those things you have to take. All the inefficiencies of motors and controllers, they are not 100%. You give 100 units of power, motor uses only 95, 5 units gets converted to heat. Controllers are inefficient. Whatever inefficiencies are there are various losses which may amount to 10 to 20%. We have to take all of that into account, and that much energy is extra used. Energy efficiency at lower speeds may be lower. If you try to drive at very low speed, it is also lower. So, you have to worry about all these things and say this is the total energy consumed. You also have to take what is the energy consumed by all the auxiliary units. Air conditioning, for example, can consume a significant amount of electricity, or power brakes and power steering. Of course, you do not use it all the time, but also all the communications, small energy used, but used over a long time. Your radio is on all the time. All that basically energy has to come from the battery. So, to that extent range will go down. So, power used is power used by the motor for the inefficiency, for the inefficiency of the controller, motor inefficiency, controller inefficiency, plus all the auxiliary power used. This is the power used, and from this you have to compute the energy used for a range, and of course, the peak power. Peak power will mean more current, so C rate. So, you have to, that is how the power, battery power and range required will be computed. We will get into details of all of this as we go further, but battery designed for certain energy, certain kilowatt hour. Battery is said to be 2 kilowatt hour, 10 kilowatt hour. Basically, how is this computed? Which the voltage of the battery is taken, what is sometimes called ampere hour. This if you multiply, you get kilowatt hour. Watt hour, voltage into ampere hour. You divide by 1000, you get kilowatt hour. So, sometime battery will be said it is 60 ampere hour, 48 volts. So, you have to multiply 48 into 60, divide by 1000, that is a battery capacity. So, cells comes with a capacity of ampere hour. So, therefore, very often batteries are specified in terms of ampere hour and voltage. So, you can compute the total energy the battery has. As I told you, for long life of rechargeable battery, it is never fully charged or emptied. You leave certain percentage on the top, certain percentage on the bottom. So, you use only X percent, typically 85% of total capacity. So, actual battery capacity is not what you calculated here. This multiplied by the X percentage. Similarly, as the battery starts getting used more and more, its capacity starts going down. So, what you define is what is called end of life. When the battery capacity is only Y percent, let us say typically 80% of the original energy, you say, well, time to replace. So, when you talk about range, you have to worry about, is it a new battery or is it an old battery, and what is the percentage remaining, capacity remaining. Let us take Y. So, in the worst case, capacity will be X into Y into C. C is the original capacity, Y because it is towards the end of the life, X because you are not going to fill it fully or empty it fully, and therefore, if you take that as 0.8 and 0.85, only 70% of the capacity. So, you started with 1 kilowatt hour, towards the end of life, the effective battery usage is 0.68 kilowatt hour. So, to that extent your range will get limited. These are important things, often not understood, and I wanted to do these things as a part of the introduction. Now, the other important point that I have already pointed out, even if the battery has sufficient energy, what is the rate at which you are going to draw the power out? That is limited because life depends on that. Similarly, while charging, you may want to charge fast, life depends on that, and you have to worry about that. Higher rate charging, discharging also heats up the battery. Heat further impacts the means temperature going up, further impacts the life of the battery. So, battery has to be designed for certain peak power capability that vehicle requires, and certain charge discharge rate depending on the battery and the nature of cells. And we will discuss all of this in great details in a battery design chapter. And I come to the homework assignment, where you basic things about depth of discharge, the initial capacity, end of life capacity is being asked for. This completes the first part of chapter 1, that was introduction overall to the electric vehicle, and now we will come to 1B, which will look at specifically electric vehicle in India, the policies with respect to India, what are the pros and cons, and this is getting into more of policy and economics. I will do that from the next class onwards. Thank you very much.